Welcome back. Today's problem involves calculating E-value when considering isotonicity of solutions. Here's the problem. An ophthalmologist requests 30 ml of tobramycin 1% ophthalmic solution, which is a fortified strength used for sight-threatening Pseudomonas keratitis. The clean room only stocks tobramycin 0.3% solution and bulk sodium chloride for tonicity adjustment. Tobramycin does not dissociate, so its dissociation constant I equals 1 and has a molecular weight of 468 gram per mole. The goal is to compound a final preparation that is isotonic with tears, so normal saline, 0.9% sodium chloride. Other givens are the molecular weight of sodium chloride is 58.5 gram per mole, and its dissociation constant is 1.8. The question is, how much sodium chloride must be added to the 30 ml batch to achieve isotonicity? A, 190 milligram, B, 249 milligram, C, 300 milligram, or D, 405 milligram. Please pause this video and see if you can solve this problem. Now, this problem essentially is asking you how much sodium chloride you need to add. So this is essentially what you need to calculate to see which is the correct answer. So this is essentially because we are looking at the I for this problem, we want to keep the solution isotonic. So we are looking at 0.9% sodium chloride. You have to see how much is required. And then also you need to consider that how much sodium equivalent is being contributed from tobramycin. So you subtract that from how much you need in the solution. So essentially sodium chloride equivalent of drug. So essentially the first step is to calculate E-value because we need to know the equivalent here. We do need to calculate E-value. So calculate E-value. So dissociation factor or ionization, some people will call it, which is why the symbol is I, is determined for the drug. And non-ionic compounds do not dissociate. So for example, tobramycin doesn't dissociate. So for such compounds, dissociation factor I equals 1. For sodium chloride, I is 1.8. And 1.8 essentially means that 80% of the compound will dissociate in a weak solution. Now, body fluids are isotonic, having an osmotic pressure equivalent to 0.9% sodium chloride, so keep that in mind. The relationship between the amount of drug that produces a particular osmolarity and the amount of sodium chloride that produces the same osmolarity is called the sodium chloride equivalent or E-value. And essentially the equation for E-value is E equals molecular weight of sodium chloride times the dissociation constant of the drug, so I of drug, and then in the denominator you have molecular weight of drug times I of sodium chloride. And essentially these values are given to you. So the molecular weight of sodium chloride is 58.5 and I of tobramycin is 1, and then the denominator you have molecular weight of the drug for tobramycin is 468 and I of sodium chloride is 1.8, and when you plug this into your calculator you should get approximately 0.069. And what this means is that 1 gram of tobramycin produces the same osmotic pressure as 0.069 gram of sodium chloride. So this is the E-value. So this is grams of sodium chloride. That's how much 1 gram of tobramycin would be equivalent to, or you might consider 69 milligram of sodium chloride. Same thing. Now that we have E value, you go to second step, which is determine grams of tobramycin in the final product. So determine now the final product, essentially this problem tells you that you want a 1% tobramycin solution. So 1% solution, this is essentially weight per volume. So you translate this into 1 gram of tobramycin per 100 ml of solution. And then you use this to see how much you will have in your final product, which is 30 ml of this. So, because the problem tells you they're requesting 30 ml of this solution. So you multiply by 30 ml, and that will give you how much of tobramycin will be in your final product. So this essentially will be 0.30 grams of tobramycin. Then the next step, step 3, is to find how much sodium chloride equivalent the drug is supplying. So essentially, how much sodium chloride equivalent is Tobra contributing or supplying. So essentially you will use the equation sodium chloride equivalent equals how much of the product we have. So we're going to have in the final product 0.30 grams of Tobra. And then this is where you use the E value. So you multiply it by the E value, which is 0.069. So you have to make sure this is in grams, since our E value here is in grams. And that will give you gram equivalence of sodium chloride, which would be, if you type this into your calculator, would be about 0.0207 grams, which we can say is about 20.7 milligrams of sodium chloride. And now we go to the next step, step 4, which is calculate total sodium chloride required for isotonicity. In the final product. So the final product, which is 30 milliliters. So essentially for isotonicity, we're looking at 0.9% sodium chloride. So you convert this to this concentration is essentially means 0.9 gram of sodium chloride per 100 ml. And we have we're going to have 30 ml in the final product. So if we have 30 ml, essentially means the final product, if we want it to be isotonic, it will have this much sodium chloride. So you plug this in and you should get so ml and ml cancel, so this will give you grams. So 0.27 grams, which you can convert to milligrams. So this will be 270 milligrams. So you're supposed to have 270 milligrams of total sodium chloride equivalent in your final 30 ml to keep it isotonic. So then you need to see, you subtract how much tobramycin is contributing to this 270, and then the remaining will be how much sodium chloride you add. So step 5 is essentially, you know, the equation we started with. So sodium chloride to add equals, so 270 milligram is how much we want in the 30 ml, and tobramycin is contributing 20.7 milligram. So you subtract this from 270, and this should give you about 249 milligram. Which is choice B. So again, make sure that you understand the E value and how to use it in order to see how much sodium equivalent is your drug contributing to the solution, and then you add enough sodium chloride to maintain isotonicity of your solution. Make sure you like and subscribe, and until next time, take care.